So this is 8.5C in trigonometry, and we're on the bottom of page 360, where it says, one important difference between rectangular coordinates and polar coordinates is that while a given point in the plane can have only one pair of rectangular points, this same point can have an infinite number of pairs of polar coordinates. Okay, let me explain it this way. When you have an xy axis, and I have a point right there, and let's say that is point 2, 3. That can be labeled with only 2, 3. We put any other number in there, and that point is somewhere else. So 2, 3 is a unique point that you can only label as point 2, 3. And what the book says, when you use the polar form, there are an infinite number of points or ways to label the same point. So for example, let's make our pen a little bit bigger and use blue. Let's talk about this point right there. That point is up 50 degrees. And how big is this? 1, 2, 3, 4, 5, 6, 7. Okay. But what happens if we go around here 360 degrees and then go up another 50? Our length is still the same, but now we're at 410 degrees. Or what would happen if we started here, went around once, twice, now we're at 720 plus 50. So we're still at the same length, but we went up 770. And I mean, you can go around and around and around. And the other situation that you can get into, which gets kind of tricky, is let's say I start here and I went around this way. So I went around negative 3, should be 310. And I still had a length of 5. So I'm still at 1, 2, 3, 4, 5. I'm still at this point right there because this is 5 long. Okay, so that's another way of labeling it. Let's see, what else could I do? I could, alright, see if we can leave our drawing here for that point there. Let's say that I went from here and I went to here. That's negative 230, and my R is 5, but I'm not saying I'm going to end up at this point right here. I want to end up over here. So how do I go from here to here? I change the sign on my 5 to a negative. Now that point that I'm showing right here says go negative 230, 5 long, and go the opposite direction. So there's another way of writing that point. And yet another one is to go negative all the way around here. Oh, I guess I already did that one. Go around this way to here, and then take the opposite of the 5. So there's really, I mean, within that 360 degrees, there's 4 different ways to label this point right there. And that's what they're doing for example 2. So I'm going to give you that one just to do. I'm not gonna go into how to do that because I kind of explained right there how you can show the same point 4 different ways. Okay, so the B portion of example 2 says determine 2 pair of polar coordinates for the point with rectangular coordinates negative 1, 1. I need to make my points a little bit smaller. Negative 1, 1. And I also need to do that in black. Alright, so negative 1, 1 lies in the second quadrant. So if we were to draw that, it would be right in there. It would be that point there. Alright, so one of those points, in fact, let's use kind of again a superimposed XY axis on top of this. Okay, so let's go over -1 and then up 1. We end up like right in there. Okay, so when we do that, we have a 45-degree angle there, right? Because x and y are the same number, so that's going to be a 45-degree angle. Both my sides are 1. My hypotenuse is going to be the square root of 2. So I know my r then is going to be the square root of 2. So that makes life easy, just because I know that a 45-degree angle, the hypotenuse, or the r value, this length from here to here, is square root of 2. Alright, so let's keep going here. Now what I'm going to do is I've got to try to find this angle. Well, fortunately, I don't have to do a whole lot of work there because it's a 45-degree angle, or a 135-degree angle from here. And that's what I'm interested in. So there's one of the two pairs of coordinates that I'm looking for. The other one is possibility of going around this way and giving my r would then be the same, but my angle would be a negative, whatever this angle is from here around to here. Okay, so that's a possibility. So anyway, there's other options, other possibilities there. You could find, I've got too many lines there. Let's see if I can get rid of some of this. Whoa, too many. I could find this angle, this 45-degree angle here, and then say that my r value is the opposite of that, and that would put me here. So whatever angle this is from here to here, have it square root of 2 long, take the opposite, and it would put me there. So I could label it that way as well. So the graphs that we've done so far have been rectangular, and now we're just kind of getting introduced to the polar coordinate system. And when we've used rectangular before, we had equations like 3x plus 2y equals 12. That's rectangular. In polar, it's going to be r, that's going to be the isolated one, times 3 times like the sine of theta. That is an example of the polar system. Alright, so you can go back and forth between the rectangular system and the polar system, which is what we're going to do, and pretty much come up with a formula. Now we've got this list of formulas right there, but I'm going to add one more, and the book doesn't put a whole lot of emphasis in it. It gives it to you, but it doesn't make a real big deal about it, and I think it's a pretty big deal, so I would put this down in your notes. R equals C over A cosine of theta plus B sine of theta. Now the A, B, and C, if you remember from algebra, the standard form of an equation is AX plus BY equals C. So what I'm saying is you're just going to take this number here, this number here, and this number here, and put them in there, and if you know this angle, then you can find out how long the radius is, or the length of r, in order to determine where that point is you're looking for. So if you remember from your old algebra days, this is the graph of a line. Because we have no exponents on the x or the y, this is going to be a straight line, and that's good. That's what you're used to. The other thing that you've graphed is something in more of a circular form, and if you remember, the graph of a circle is x squared plus, whoa, something's not clicking there, x squared plus y squared equals r squared. Okay, so if you have that for a circle, when you change it to polar form, you're just going to get r equals plus or minus a is what you'll end up with. So, for example, or I'm sorry, this would be r. No, that's r too. Okay, let's go ahead and actually do this. So there is your formula for a circle, but we're going to use a squared instead of r. So x squared plus y squared equals, I'm just using a squared as my radius of my circle just because I distinguish it between the r. Alright, so what happens here? What happens if I take the square root of both sides? I get the square root of x squared plus y squared equals plus or minus a, right? Well, from up here, r squared equals x squared plus y squared. Square root of both sides, I get r equals the square root of x squared plus y squared. And that's what I have over here. So r actually equals plus or minus a. Okay? And I say negative because remember the r value, sure, the radius is positive, the distance is positive, the measurement is positive, but it can go in a negative direction. Alright, so anyway, we'll go ahead and use some of this stuff in the next video, and we'll start with example 3.